Right. So good evening all of you. The summary of the last lecture we have discussed this photoelectric effect, right? So the photoelectric effect means the electron which is tightly bound is accepting the energy completely, and that electron is ejected, and we have done some problems also today. Okay, right, shall we go to the next one? So today we will be having a lot of derivations, a lot of formulae. My humble request, online and offline students, please take a rough paper with you. Plenty of things are going to come. It's very difficult to remember. So please keep on write 5 times, 10 times each formula. Please keep a rough paper with you. Right. Now take a fresh page and put the heading Compton Effect. Compton Effect. So I hope the introduction I have given in the last class. What is this Compton effect? Right. So this is about scattering of X-rays. So what is the problem with the classical? Whenever X-ray is scattered from the material, whatever the X-ray incident frequency, scattered frequency also must be same. Or whatever the wavelength incident, scattered wavelength also must be same according to classical electromagnetic theory. But Compton observed little bit different thing. So let us discuss. Very important. All of you please listen. This is about scattering. Right. Now here, this is my incident X-ray. This is X-ray, high energetic X-ray. So of energy h nu. Okay. Or we can say its momentum is what? H nu by c, because E equal to h nu. And we can say what is the relation between momentum and energy of a photon? E equal to Pc. Very good. Listen. If anybody don't know about this, listen. If you take a photon, what is the photon rest mass is 0. What is the photon rest mass? 0. Photon is a relativistic or non-relativistic? Relativistic. So that's why relativistic particle energy equal to E equal to under root P square C square plus M naught square C power 4. Now you are talking about photon. Photon rest mass M naught is 0. Then this term is, then energy E equal to how much? So in BSc there was a question. E equal to Pc is valid only for photons? E equal to Pc valid for photons? Say yes or no? Why? Rest mass is 0. Now my question is, E equal to Pc valid only for photons or any other particles? Whose rest mass equal to 0? So that's why in nuclear physics, please remember this, we will study particle dynamics. There we will take the rest mass of neutrino. Neutrino. We take in the derivation, we will take the mass as 0. That's why there we will use the energy of that neutrino E equal to Pc. Not only for photons, those particles whose rest mass equal to 0, we can use happily E equal to Pc. Won't forget, ma? Right. That's it. And this is the photon. That's why I have written momentum. H nu by C is nothing but what? Momentum. Energy is what? H nu. Now tell me, if it is a photon, what is the momentum? E by C. Everybody got it? Right. Now here we have an electron which is at rest. Rest. This is at rest. Right. Now after that, this is a scattered photon and this is a recoiled electron. The electron is recoiled at an angle theta and this is at an angle phi. So this is what they observed. Okay, fine. Right. Wait a minute. So these people. right? We can't help. So this is the Compton effect, what they observe. So this is the energy h nu, and here what is the energy? And lambda, we can say this is a hc by lambda prime. Dash prime. Right, this one. Okay, so what is this Compton effect and what we are going to do here? So first, assumption. Anybody knows what is the assumption made by Compton? Whenever you want to say the answer, stand and say. Assumption. Assumption is both photon and electron are relativistic particle. What particles? Relativistic particle. That's it. So what is the meaning of relativistic particle? Whose energy E equal to under root P square C square plus M naught square C power 4. So this is the assumption. Next, concepts. What concepts we are going to apply here? Not at all difficult concepts, but you feel difficult because first time you are doing some derivations, okay, yourself. Concepts, first one, law of conservation of momentum. Next one, law of conservation of energy. Only these two they have applied, nothing else. Compton effect is completely based on law of conservation of momentum and law of conservation of energy. Okay. Now first I am taking law of conservation of momentum. Right. So that is nothing but initial momentum equal to final momentum. Whenever you are applying the LCM here, law of conservation of momentum, here you are having two directions. One is x-axis, another is y, horizontal as well as vertical. So I can take this as x and I can take this as y. Something like this is minus y minus x. So now I am going to resolve this. All of you please observe. Because here what is the momentum we have? H nu prime by c, and I am assuming the electron momentum is p. P stands for electron momentum. Photon momentum h nu prime by c. Initial momentum h nu by c. Everybody got it? Good. Since it is not horizontal or vertical, whenever any vector is horizontal or vertical, no need to resolve. Whenever a vector is inclined, then you must resolve. So I am going to resolve. How to resolve? How this is going? Rightward or leftward? Right or left? Right, one line. Is it going up or down? Up one line. Clear? So now this is the angle. How much angle? Phi. So that's why h nu prime by c cos phi. Now this is h nu prime by c sin phi. Generally you will think horizontal is a cos, vertical is a sin. Not like that. It depends upon the angle. Always whenever a vector is there, you have to see how it is going. For example, it is like this. This is the tip of the vector. How it is going? Up or down? Down one line. Right or left? Right or left? Right one line. Now your vector is like this. Okay. Now up or down? Right or left? Up or down? Left or right? Ante. Only these are the resolutions, because all vectors are plane vectors. That's why plane vector resolution is in a plane, up or down, right or left. Is that clear? Yes, sir. Right. Now come to this. So momentum is a P, it's a vector. How it is going? Up or down? Down. Down one line. Right or left? Right one line. So no need to get tension. Theta, what is this? P cos theta, and this is a P sin theta. So I have already resolved everything, and this is the initial and this is the final. Now I am taking law of conservation of momentum. First one, along x-axis, and the second one I am taking along y-axis. Now I am taking along x-axis. See, this is the initial, that means before the collision, and this is after the collision. Yes, come on, I have not done any difficult thing. If you are feeling difficulty means you don't have the knowledge of vector resolution. So how the vectors will be resolved, the intermediate. So if the vector is going up or down, you have to see carefully where, in which direction it is going, up or down, right or left. These are the only 4 resolutions. What are those? Right. Okay. So this is the initial momentum. Tell me, what is the initial momentum along x-axis? Slowly. This is the initial, equal to final along x-axis. Along x-axis you have h nu prime by c cos phi plus p cos theta. That's it. Okay. Now if I take LCM, here what is LCM? So I have to multiply here c. So this c and this c gets understand? Then h nu equal to h nu prime cos phi equal to plus p cos theta. Am I right? Pc cos theta. Shall I write like this? Okay, some people don't understand. Ready. H nu equal to h nu prime cos phi plus pc cos theta. I don't multiply, c square. Okay, leave it. Now from this I would like to find a pc cos theta. So pc cos theta equal to h nu minus h nu prime cos phi. Can you write? Okay, please write yourself. Next, come to y-axis. Initially along y-axis, any motion? That's why 0. Initial. Now equal to final. Finally, any motion along y-axis? Up, positive. Down, what is up? Down, minus p. I think I can bring this term this side, and here I multiply with the c. Then what I will get, ma? Super. So similarly here also you will get a pc cos theta something. So what you have to do, next one, I request you square this and add. Can you do it? Start. don't copy. If you copy, you won't get confidence. P cos theta equal to, here you will get, I think, h nu minus h nu prime cos phi. So just square and add, just square and add. Square and add, added. So what is the value you got? Please check. P square C square equal to h nu whole square plus h nu prime whole square minus 2 h square nu prime cos phi. So once again, please check the value. Answer: P square C square equal to h nu whole square plus h nu prime whole square minus 2 h square nu prime cos phi. Please do it. Please do it. Why we will do the derivations means only to get the confidence whenever you are solving the problem. Without derivations, if you remember the formula, you won't get confidence whenever you are solving the problem. Listen carefully, observe carefully, and after that present it in your, write all these things in your notebook without seeing the board. Try. That is the best method. Please try. Ready? Shall we proceed? Sorry. Right. So I think you got this answer. PC whole square equal to h nu whole square plus h nu prime whole square plus 2h square minus summa. Here minus, they are saying, please check, nu prime cos phi. All have you got this? Okay, ready. So this is, we got from law of conservation of momentum. This we got from law of conservation of momentum. Right. Now here I am taking law of conservation of energy again. So observe carefully. Once I started, you please stop the writing and see the board. While explanation is going on, don't write please. Now here, this is the incident energy h nu, and here is an electron, and this is the h nu prime, and this is the electron. Don't think you are studying MSc high level things. These are BSc things. Photoelectric effect, Compton effect, you should study in BSc. But unfortunately, now you are studying. This is the condition. Now what is the incident energy? Scattered energy? So definitely we observe, they observe nu prime is less than nu. You are sending high energy scattered with some less energy. That remaining energy taken by electron as, now tell me, how much is sending? You are here, you are getting, so the remaining energy is taken by, that means initial energy h nu equal to h nu prime plus kinetic energy of electron. So just I have written K. I think from this I can write the kinetic energy of electron equal to h nu minus, shall I? Super. So this is from law of conservation of energy. So once again what we have done, just apply the law of conservation of momentum and law of conservation of energy. Now come to this. Okay, so I told you already, electron is treated as a relativistic. This momentum is electron momentum or photon momentum? It means you are not listening anything. This P is a photon momentum or electron momentum? Electron momentum. Photon momentum is what? H nu by C, H nu by C. Electron momentum is a P here, right? So electron is a relativistic particle, slow. Relativistic particle. What is the energy of relativistic particle? E square equal to P square C square plus m naught square C power 4. Now from this, shall I take this? Now tell me what is a P square C square from this? P square C square equal to E square. Super. Now I am going to replace this P square C square with this. Shall I replace? Please, if you are not understanding, please ask. I am not doing any difficult mathematics, simply just bringing this side and that side. Now P square C square equal to, good, wait. Right, that's it. Now this is what? This E stands for energy of electron or photon? Electron total energy. Electron? Is it a relativistic or non-relativistic? What is its total energy? Okay, I'm here. Now I'm moving. What is my total energy? Kinetic energy plus. Now that electron total energy is what? Kinetic energy. Potential energy is not there. Special theory of relativity, and there is no interaction between anything. So that's why what you have to take, potential energy interaction is not there. Then what is the total energy? Kinetic energy plus rest mass energy. There is no interaction, or we neglect the interaction. We are not considering those interactions because no other particles, we are just considering only that electron. Understand? So in special theory of relativity, we would consider those interactions, and it's purely the total energy is equal to kinetic energy plus. General theory of relativity is different, that we cannot talk about all those things now, right? So whenever a non-relativistic particle is there, definitely total energy is always equal to kinetic energy plus potential. In STR, we will take only kinetic energy plus rest mass energy. Please remember. So this total energy equal to kinetic energy plus rest energy. Okay, so that's why I can write this E as kinetic energy of electron plus rest mass energy. What is the rest mass energy? mc square m0 c square whole square. See, I am not doing any new thing. Total energy is the kinetic energy plus rest energy, just substituted. Minus, come on, say. First, let me simplify this because it's a waste of time writing again and again and again. This is not a school, okay? First, let me simplify this. A plus b whole square. Cancelled? Thanks. So, a square plus 2ab plus b square and this term gets cancelled. Now I am writing. See, mathematics means, if you are doing mathematics means, you are simplifying the above step. But generally what we will do mistake is, we will search for the steps. And we are not choreographers to make steps. No need to prepare any steps. Just see the above step and simplify by using a formula. Or by simplify by using relations. That's it, that's the mathematics. No need to get tension. See here, we have written this. And after that we substituted. After that again substituted, simplified. That's it, that's the mathematics. Tension padalsin pani ledhu. Minus 2h square nu prime cos phi. It's cool. Right. Aya, till now you have taken only LCM, means law of conservation of momentum. I have not applied this anywhere. See, anywhere did I apply? No, till now I didn't apply. Just we have written law of conservation of energy. Check whether I applied or not. Sure. Right. Now I am taking this law of conservation of energy. What is the kinetic energy? Please tell me. K square. What is a K square now? K, see, I am substituting now. I am not creating any step. Right, H. This one as it is, no need to write again. Now please simplify. H square nu square. See, this is a minus b whole square. H square nu prime square minus 2h square nu prime plus 2h and let me write this again, the right hand side. You should not get fear by seeing the mathematics. Mathematics is the simplification of above step. Now see, Ante, that's it. Very good. No need to get tension. Right? Now please keep this this side only, and yeah, your wish. Can you bring this term that side? Yes. Come on, simplify. Why you are bringing? Because this one and this one is quite similar. Be confident, be confident. Don't see the board, please. If you want to see, just see for 2 minutes what they have done. 1 minute. Oh, this is the expression. So PC, they substitute that PC from the energy of relativistic energy. Cool, substituted. After that, what is E? Total energy, kinetic energy plus rest energy, substituted. And after this, this is the time to apply law of conservation of energy. This expression and substitute it. Do it yourself, you will get a lot of confidence. Don't feel that you are doing a difficult things. Be proud that I am learning difficult things. If you feel some difficulty, just be proud. Oh, I am learning some difficult things. Then it will give you some positive energy. Don't see, don't see. If you forget something, try to recollect by seeing the above step. If you simply take the help, you won't recollect. The human brain functioning is a typical and magical. If you ask, it will give you anything. But immediately don't depend. Just think. Because a few minutes back we have seen the board. Completed. Try to do it yourself. Try to do it yourself. Whenever you forget something, try to recollect. Just take the LCM equation, and after that take the energy, replace this with the energy relation of electron, relativistic energy, and after that just proceed, substitute. And here we are using the total energy from STR, special theory of relativity, so which is a kinetic energy plus rest energy, and this is a plus b whole square, and this term cancel, the right side term as it is. And now this is the time to substitute law of conservation of energy. That's it. I think you are bringing this term this side, right? If you bring this minus term that side, what you will get? A plus positive? Yeah, come on, take common. Please take common. And do any simple cancellations are there, please do that. Shall I proceed? Online students, I request you don't take any photos, please. Later we will see, later we will write. That laziness should not be there. If that is the attitude, we never achieve anything. Right? So I think left hand side you have 2h square, this term, sorry, h. So please tell me, Amma, what is the term? 2h nu minus nu prime m naught c square equal to, I think you bring this term that side, then it is a positive, 2h square nu prime, take common, 1 minus cos phi. All of you got this? No, still some people are not saying anything. Completed or not completed? Ma, listen. till now, from BSc or intermediate or BSc onwards, we are copying, copying, copying. That's why you are like this. Now at least there is a chance to change yourself. Please change. Okay. So if you are writing like this, what will happen? You won't think. If you are not seeing the board and writing, what will happen? You are giving some instruction to your mind, your brain, recollect, remember. This is the process. Observation and recollection. So please do like that. Don't simply depend on the copying the things. Right. Okay. So now I think 2h and 2h square gets cancelled. You got nu minus nu prime equal to, I am writing this as h by m naught c square nu prime into 1 minus cos phi. Just nothing, only just I cancelled this, that's it, and I bring this m naught square, this m naught c square this side. Now I am going to divide the entire thing with this, shall I? If I divide this with this nu prime, please divide with nu prime, nu prime, nu prime. These two gets now here nu by nu prime, nu prime by nu prime equal to h by m naught c square into 1 minus cos phi. You must remember this. You must remember this, because in further derivations, later derivations, this formula is useful. So I request you, please remember, what is that? 1 by by seeing this, everyone will say, okay, right? So recollection means you should not see, you have to see somewhere else and recollect. If you want to remember, recollect past, in which direction you will see? This side. If you want to recollect future, if you want to see your future, this side. Subject, this side. Ready? So 1 by nu prime minus 1 by nu equal to h by m naught c square into 1 minus cos phi. Okay, good. So don't forget this. Now what I am going to do is just multiplying with the c by nu prime minus c by nu equal to h by m naught c into 1 minus cos phi. Can you please tell me what is a c by frequency? Lambda. Sure? Oh, super. Lambda? Minus? Lambda. So what is this lambda prime minus lambda? That's good. Shift, Compton shift. See, you have done the first derivation in your coaching. So this is Compton shift. What is the Compton shift? Delta lambda equal to I told you, my online students also, please keep a rough paper with you. So I said this you must remember for the further derivations and that Compton shift. So after writing this, what you have to do? Write the formulas 5 times, 3 times, 4 times. Don't copy. This is not at all difficult. 1 by nu prime. See, whenever you are trying to recollect, you will get a doubt whether it is 1 by nu prime or first 1 by nu na. Here it's okay, now it is okay for few minutes for one day, but after 6 months you are going to write the exam. You won't remember because many subjects will come, many formulas will come. Understand? That's why you have to use that rough paper, write again and again and again. One by nu prime minus 1 by nu equal to h by m naught c square into 1 minus cos phi, and delta lambda equal to h by m naught c into 1 minus cos phi. Over? So everybody come on, say what is the first formula in this derivation, 1 by nu prime, this one. Everyone don't see the board, just close your eyes and say. No rhythm. One more time. Compton shift delta lambda equal to. Seeing and saying, don't see there. Compton shift delta lambda equal to. Good. Ready. Now let us start the application. Now first one. Compton wavelength. Compton wavelength. Ready. So please listen, please listen. Very important, very important, very important. So after that, tomorrow we will get a de Broglie wavelength. Okay. So here onwards we are entering into the subject. So I request you please be serious and please practice everyday class notebook. Please practice in the rough paper one more time, two more times. Okay. So today after the class, go back to the room and practice the notebook, and tomorrow 9:30 come for the working. That's it. Okay. Till 9:30 it won't be activated. Once you came here, then only for you and for them at a time it will be activated. Understand? Working is 9:30 to 12:30. In that time it will be activated. Right. Okay. I will explain after the class. Ready. Compton wavelength. Okay. So here we have Compton shift. Just now we discussed. That is delta lambda equal to h over m naught c into 1 minus cos phi. Cool. Now what I'm doing is I'm taking different angles, different scattering angles. What is this phi called? Scattering angle of the photon. Scattering angle of a photon, gamma written, X-ray gamma. Okay. So if I take a phi equal to 0, take phi equal to 0 and substitute cos phi, cos 0, 1 minus 1, then delta lambda equal to 0. If the scattering angle is a 0, is there any change in the wavelength? That means initial wavelength and final wavelength both are same. Initial energy and final energy both are same. Then the electron is gaining any kinetic energy or not? No. Forward scattering. So in this forward scattering, electron won't gain any energy because there is no shift in the wavelength. Understand? Yes, in this case, the kinetic energy of electron is 0. Because there is no change in the incident photon energy. There is no change in the incident photon wavelength. Whatever the change is there, that change is taken by electron. But here there is no change. Clear? Right. Next one. I am taking phi is equal to 90 degrees. Now please take this phi 90 and substitute. Cos 90? 1. మీరు ఈ స్ట్రోక్లు ఇవ్వకండి, అసలే 50 years వచ్చేసినాయి, ఎప్పుడు పోతామో తెలియదు. కాస్ 90 1 ఏందమ్మా, కాస్ 90 0. సో దెన్ డెల్టా లాంబ్డా ఈక్వల్ టు h by m naught c. Why we will say wrong answers? Two reasons are there. One is lack of perfection, another is overlap. ఇక్కడ ఆన్సర్స్ ఏమవుతాయి అంటే దే విల్ బికమ్ సూపర్ పొజిషన్ అనమాట. ద వేవ్స్ విల్ impose each other and destructive interference, and intensity is 0, answer is also 0. So h by m naught c. Good. Next one, I am taking phi equal to 180 degrees. Cos 180? Oh, super. Then delta lambda equal to 2h by m naught c. Wait a minute. Right. So could you please tell me what is this? Here we have taken scattering angle is 90 degrees. What is the meaning of that? Yeah, perpendicular scattering. This is the incident photon. Here you have electron, and the scattered photon is scattered perpendicular to the initial direction, 90 degrees. Okay, of course electron is scattered up, recoiled. So whenever the scattering angle is 90 degrees, whatever the Compton shift you got, please tell me what is the delta lambda? That Compton shift is called Compton wavelength. For 90 degrees of scattering, delta lambda equal to lambda c equal to h by m naught c. So the Compton wavelength means Compton shift. For angle of scattering phi equal to 90 degrees. If the scattered photon is scattered at an angle 90 degrees, then whatever the shift you are observing in the wavelength, that shift is called Compton wavelength. Compton shift kaadu, Compton wavelength. So what is the Compton wavelength? Lambda c equal to h by m naught c. So if it is 180 degrees, delta lambda equal to twice the Compton shift, Compton wavelength. Say yes or no? Yes, sir. So this is the maximum one. Maximum possible shift is how much? 2. Why? Photon cannot scatter more than 180 degrees. 270 degrees, 190 degree, 200 degrees, not possible. Only maximum scattering angle is what? 180. We'll derive that, don't worry. Just we are not giving any statements like that. So this is your last coaching in your life. By bad luck you came here, okay? So you have to learn and go. That's it. So this is about Compton wavelength. So Compton wavelength is nothing but Compton shift for the angle of scattering phi equal to 90. Clear? Right. Now in the GATE exam, they ask one question. The GATE exam. So here we have the Compton wavelength lambda c equal to h by m naught c. What is m naught? Rest mass of the particle, for which is just like a target. Say yes or no? This is the electron, which is the target, and the photon is coming and striking and scattered. So this is electron. Okay. Now see carefully. Now this is the Compton wavelength. If I take the target as electron, what is my target? Electron. Then the Compton wavelength equal to h by mass of electron into c. If you substitute all these values, you will get 0.0242 angstroms. 0.0242 angstroms. Amma, you won't remember. Shall I tell you, shall I ask you one thing? Okay. How you learn mother tongue? You are perfect in only one thing, that is mother tongue. You are not at all perfect in any other thing. We are all. How you learn mother tongue? You went for coaching? How you learn? Someone is speaking, you listen and reproduced. But you people are simply, some people are simply sitting and seeing like this. Now your mother tongue is physics, this one, you are learning now. As long as you are not reproducing, you won't remember single thing. Because 9 topics, 9 papers. We feel that we know everything or we have so much memory. Impossible. Our memory is very, 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 very less. We are not using properly because other things, so many other things are there. Okay, right. Compton wavelength, lambda c equal to how much? 0.024 angstroms. 242 angstroms. For? Or we can write it as a 2.42 picometer. Picometer 10 to the power of minus 12. 12. This is 10 to the power of minus 10. This is 10 to the power of minus 12. The gate question is, instead of electron, I have taken proton. What is the Compton wavelength? That's the gate question. Everybody will study, but they are asking this one. If you have proton, okay, then what is the Compton wavelength? Compton wavelength is the same formula for any particle. What is that? H by MPC. Here m is the mass of proton. Do you know proton mass is how many times greater than electron mass? Very good, very good. Sebash, sit down, sit down. Lambda c equal to h by 1836 mass of electron into c. Mass of proton is how many times? 1836 times. 1836. 1836 any war happened? 1857 are they? Okay, right. So we can take nearly 2000, no issue. So that's why lambda c equal to, what is h by MEC? Compton wavelength of electron. So I can write Compton wavelength of electron by then this 1.32 Fermi. How much? 1.32 Fermi. So the Compton wavelength of proton is nearly 2000 times less than Compton wavelength of electron. So that is 1.32 Fermi. 1.32 Fermi. Come on. This is the Compton shift, and this is a shift for different angle of scatterings. A zero angle scattering, that means there is no scattering, it's a forward, it's going as it is. If going as it is means there is no change in the energy, that's why kinetic energy of electron 0. And a perpendicular scattering, then whatever the shift we are observing, that is named as a Compton wavelength. But the exam they ask this question, Compton wavelength of proton, just nearly 2000 times less than the Compton wavelength of electron. Online students, regularly please check the mails. There is only one communication between you and us, is news scrolling in the application and mails. We won't send personally any WhatsApp messages. Please check the mails, please. Right? Ready. Now, Orama. Now tell me, I told you one formula you have to remember. Don't see your notebook. Now try to say 1 by whenever you are trying to remember something, don't by heart. Generally what will happen, formulas means some slight variation will be there from one formula to another formula. Then what we have to do, what is that difference you have to remember. Compton shift h by m naught c, and another formula what I told you to remember, h by m naught c square. Rest of the things the same. Like that, first you have to give instruction to your brain. So then you will easily remember 1 by nu prime minus 1 by nu equal to h by m naught c square into 1 minus. Difference we have to identify, not similarity. Difference, not similarity. Similarities will be there, so many things, it's very difficult to remember. Difference, what is the difference between this formula and that formula? Then you can easily remember. Right, ready. Okay, second one. The second application is about, nice one. If you practice these things, tomorrow you can do the assignment, otherwise impossible to understand. Energy of scattered photon. So here we are going to find the energy of a scattered photon. Are you ready? Right. Now see, this is the incident energy, let us say E, electron, and this is the scattered energy, let us say E prime, and this is the electron recoil with kinetic energy. And already we derived, no need to do it again. So I told you, please remember one relation that is a very important. Please tell me. By what they are asking, Amma? Energy of scattering photon means what, Ma? E prime. Could you please tell me what exactly E? What exactly E? H. What is E prime, Ma? H nu prime. So this is the relation you know. From this, what you have to find? If you want to find E prime, from this relation, what you will find? Nu prime. So 1 by nu prime equal to, bring this side, take LCM aram se, don't get attention, you are not at all doing a Ramanujan problem, okay. So bring that side, confidence, faith, confidence, bring that side and take the LCM aram se and reciprocate it, understand? After LCM, reciprocate it, then what you will get? Then multiply with the, come on, try. It's a school level algebra. Just LCM, nothing else. In the exam, no one will help you. Just remember that situation, how to handle. Whenever there is no help from any others, then we will know the strength. What is our strength, we will know. Simplify the above step. Simplify the above step. Here different, that's why just cross multiply by both multiplication, that's it. Cross multiply by, you just multiply these two. Bring this here, plus bring this here, by multiply both. Now reverse, reciprocate it. Don't copy, don't copy. Now bring this minus bring this m naught c square to denominator. That means divide numerator and denominator with m naught c square. Simplification, nothing else, just simplification. Divide the numerator and denominator with m naught c square. Or bring this m naught c square to the denominator. Here 1 plus h nu by m naught c square into 1 minus cos phi. Now happily, please multiply with the h here, h here. So this h nu prime, e prime, and this is nothing but e. Now I hope everybody got the relation. E prime equal to, you must remember, E prime equal to E by 1 plus E by m naught c square into 1 minus cos phi. I told you, keep the rough paper and keep on write. See, h nu is E, h nu is E. Please follow that same technique till the end of the coaching. I won't say again and again. If you want to learn, do it. Now E prime equal to scattered photon energy, E prime equal to E by 1 plus E by m naught c square into 1 minus cos phi. Dimensions, energy, energy, energy by energy, constant, constant. This is a constant. Like that also we can remember. So what should be the denominator term? Sometimes we will forget, like this. So E prime equal to One more time. E prime equal to write down, write down, write down. You won't remember. Just 6 months, whatever I said, just do it, please. You will get the subject. My online students, please keep the rough paper and please write down, please write down. It's impossible to remember all these things. Why we will remember? Many times I have written na. Simple. Many times we have written, that's why we will remember. You will write how many times? For each batch we have to write, we will remember. That's why there is a quote. The best way of learning is to teach someone. So now I request you, you please do the next one yourself. Take phi equal to 0, forward scattering, perpendicular scattering and backward scattering. Find the values. What is E prime? What is E prime here? What is E prime here? Please substitute the 3 scattering angles. Phi is 0. If phi is 0, cos phi is 1, 1 minus 1. 0. Then E prime equal to E by, E by? E prime equal to? Thanks. Already we have seen earlier, if you remember what happened earlier. Where? Here on. Here only. Kinetic energy. Why kinetic energy of electron is 0 in the forward scattering? No change. No change. Here what is the meaning of this E prime equal to E? Final is equal to initial. No change in the energy. Next. Come on. Phi equal to 90 degrees ma. Cos 90. E prime equal to okay. Next phi equal to 180 degrees. I think here you got 2E. Right? Ready for the next one? Third one. Third one, kinetic energy of electron. So we can do it in 2 ways. I will tell you first what you have to do, because sometimes we need both the expressions. So this is the kinetic energy of electron in terms of incident energy. In terms of incident energy. What is incident energy? E. Right. Now ready. So this is the incident energy E, and this is the scattered energy E prime. and this is the kinetic energy of the electron. By using law of conservation of energy, kinetic energy of electron equal to E minus E prime. Just now we have derived one thing, E prime equal to E by 1 plus E by m naught c square into, please substitute and simplify. Don't feel it is difficult, because the first time you are doing that, that's why you feel difficult. Do you know software engineers how many times they will practice the code? One time, two time? How many times? Nobody knows. Many times, 100 times. Many times they will practice, otherwise they won't remember the code. You also must practice all these things. Don't fear, mathematics is created by human beings. Okay, so no need to worry, just have faith on you and proceed. I will write the answer, check whether you got this or not. This is E square by E plus m naught c square by 1 minus cos phi. If you get this, good in mathematics. Simplification. Nothing LCM, nothing, just LCM. Just follow that rule, simplification of above step. Just multiply, cross multiply, because this is a single term and this is a fraction. So this is a single term. So that's why take the entire denominator and multiply. E plus E into E, E square by m naught c square into 1 minus cos phi minus E divided by the entire denominator. Don't worry, just proceed. Now this E gets cancelled. Now take the LCM in the denominator and bring that 1 minus cos phi to the denominator, or cancel. Divide numerator and denominator with 1 minus cos phi. Then you will get this. Now again take the LCM in the denominator. Cross multiply, because the single term, it's a fraction. Single term, fraction. Take the denominator and cross multiply. Please do it. Please do it. Be confident. We will know the strength, our strength, only when we are facing difficulty. Divided by, just cross multiply, m naught c square plus E into 1 minus cos phi, the whole divided by m naught c square. Now m naught c square gets cancelled. Numerator you have fraction, denominator also you have fraction. That fraction denominator and this fraction denominator both are same. Just cancel. Got it? Don't copy, don't copy. If you are copying, no use. And after cancellation, write whatever you have, 1 minus cos phi by m naught c square plus E into 1 minus cos phi. Now I request you divide the numerator and denominator with 1 minus cos phi. We'll get back to this. And what you are saying, write in the rough paper. 3-4 times write. Don't waste the time. Don't even waste 1 minute. Please, please. Right. Earlier things write, earlier formulas write. Don't sit like that. Please don't waste the time. Write again. Instead of sitting like that, if you write, you will remember forever. Don't copy, please don't copy. This is in terms of incident energy. Right, Amma? Amma. Read this expression, Amma, kinetic energy of electron. Could you please tell me when this kinetic energy of electron will be 0?
The total energy is taken by the scattered photons, that is E is equal to that psi is equal to 0.
Psi, yeah.
So phi.
Phi is 0. Substitute phi 0 here. Substitute E square by infinity. E square by infinity. 0. 1 by infinity is what? 0. Once again, earlier we have discussed one thing. Forward scattering, phi equal to 0, there is no change in the scattered photon. That's why kinetic energy of electron must be 0. Now check. If you put phi equal to 0 here, cos phi 1. 1 minus 1, 0. Something by 0. Cheppandi, don't sit like that. Please say, give the response. Something by 0. Infinity. Now something by infinity. 0. That's it. So that's why for forward scattering again answer is 0. Now, I told you this is the kinetic energy of electron in another way. One more time. So this is the E, and here we have electron. This is the E prime, and this is the electron's kinetic energy. All of you? Shall I write? The kinetic energy of electron is difference in the energy of these two photons. That means E minus E prime. What is E? Energy of a photon. What is energy of a photon formula given? E equal to h nu. E prime h nu prime. Convert this into lambda, ma. This one. That's good. So this is also another formula for kinetic energy of electron in terms of lambda. So you can take kinetic energy of electron is, wait, this was the previous question. 1 by lambda minus 1 by lambda prime. Now Hc into, take the LCM, lambda prime minus lambda by, so this is the kinetic energy of electron. So we can say this is the delta lambda. So we can write like this also, kinetic energy of electron is Hc into delta lambda by lambda into lambda, something like this. So this is the kinetic energy in terms of lambda. Come on, don't see the board. One more last one is there. This is also very important. See, many derivations came. My humble request, today night you don't read any other things. First practice the notes one more time in the rough book. After that, if you have, then only read. If you properly thorough with my notebook, that is also enough, because notebook is the collection of many textbooks. Okay, first be perfect with this, then later think about any other thing. Okay, right, ready, Amma? Last one. I didn't remember the number, just I am taking 5. 5. Right, listen. Online students, have you taken this? So tomorrow we will work on this Compton effect. See, today you will learn Compton effect, tomorrow work. That's it. This is the process for 6 months. Next, a fifth one. So here we have, this is the incident photon, and this is the scattered photon, and this is the electron, and the scatter angle phi, and this is the recoil angle theta. Now the beautiful relation, we are going to get the relation between the theta and phi. What is the maximum possible value for theta? Theta is the recoil angle of electron. What is the maximum possible recoiling angle of theta? What is the max? Huh? I will say na, you paid na. I will say. Right, next one. What is the maximum scattering angle for the photon? So this is the beauty. Ready? Listen. So for this, we have to take, in the beginning, we have written law of conservation of momentum. Go back, go back, go back. Yeah, here. We have written 2 equations. One is a PC cos theta, another is a PC sin theta. Please tell me, Amma. First one, PC cos theta equal to h nu minus h nu prime cos phi. Next, one more relation we got, PC sin theta equal to h nu prime sin phi. All of you please listen. These are the relations already we got from law of conservation of momentum. Babu, even 5 minutes. Ma, listen. Just divide these two. Just divide. This is a 1 and a 2. Just I am dividing 1 by 2. PC gets cancelled. Cos by sin is nothing but cot theta, which is h nu minus h nu prime cos phi by h nu prime sin phi. Okay. Now, with your permission, so this is cot theta, leave it. Now here I am dividing the numerator and denominator with nu prime. Then h cancel. So now I am dividing the numerator and denominator with nu prime. Involve. Wait. By nu prime cancel, sin phi. Now I have to get this value. How? I told you. Remember one relation for the further derivations. Can you please tell me that relation? Very good. Sit down. This is the relation. This is also we have derived. What do you want? Nu by? If you want nu by nu prime, what to do? Multiply with nu. Say yes or no? Nu by nu prime. Just to multiply with nu equal to equal to h nu by m naught c square into 1 minus cos phi. Okay. Now you can bring this one that side. Finally we got nu by nu prime equal to 1 plus h nu by m naught c square into 1 minus cos phi. Now I am going to take this and substitute here, right? So then cot theta equal to, so this nu by nu prime equal to this entire thing. Never afraid of this mathematics. Never be afraid of this mathematics. Mathematics is created by us. Okay, right. So just take this and substitute. 1 plus h nu by m naught c square. See, I'm not writing any, I'm not creating any new step. I'm just taking in and substituting, that's it. Into 1 minus cos phi minus cos phi divided by sin phi. Now tension will start. Will be there 1 minus cos phi a, cos phi a. Huh? What is this? 1 minus cos theta. Two sin square theta by 2. See, 10th class. 1 plus cos theta or cos 2 theta. Cos theta I have taken, that's why 2 cos square theta by 2. 1 minus cos theta, 2 sin square theta. Before you come for this coaching, I have given all these formula in the application. But maybe at that time you don't know. So these are the difficulties we are going to face once we go to the coaching. Okay, all these formulas are there, trigonometry formulas are there, right? So I think I can write this 1 minus cos phi as 2 sin square phi by 2 plus h nu by m naught c square, again 1 minus cos phi. Okay now, right. 2 sin square phi by 2 by, very good, Sabas, right. Generally sin 2 theta equal to 2 sin theta cos theta, sin theta equal to 2 sin theta by 2. Super, come on. Theta cos phi by 2. Now I am cancelling this 2, 2, 2. Here sin square phi by 2 shall I take common? Okay. Then this is sin phi by 2, that sin phi by 2 cancel. And again one more sin phi by 2 is there. Understand? There is no place, that's why I am not writing. Please tell me if anyone is having difficulty. Ready? This sin square phi by 2 common, sin phi by 2 and sin square phi by 2 square cancel, sin phi by 2 by cos phi by 2. That's it. Tan into, so the relation between theta and phi, cot theta equal to, if you are not saying, you will go somewhere else. Okay, so cot theta equal to tan phi by 2. Wait, we have to discuss about this. And finally here we got cot theta equal to, one is a cot theta, another is a tan phi by 2. Are you ready? Once again say, what is the relation between theta and phi? Cot theta equal to, what is the maximum value of the tan value lie in between what? Tan lie in between 0 to infinity. Maximum value of tan is infinity. For what angle of tan it is infinite? Tan is infinite maximum value, because I told you here we are going to find maximum possible of theta, maximum possible of phi. I repeat, tan is a maximum value is infinity. When it is infinite, 90 degrees. Tan 90, cot 90. Okay. But what is the cot maximum value? Huh? Sure? Akka? ఏదో చెప్తున్నారు. ఓకే ఫైన్. సో హియర్ చెప్పండి అంతేనా? cot theta is infinity for theta value how much? 0. 180 360 ఆల్సో. ఏదో మనకేదో చూద్దాం ఎక్స్ప్రెషన్ రైటా రాంగా. Okay, first write down the expression. The expression is right. We will discuss this. Oh. So the relation between theta and phi, cot theta equal to tan phi by 2 into 1 plus h nu by m naught c square. Tan 90 how much? Infinity. Please practice all these derivations. So don't neglect. If you feel difficulty, please apply Chanakya rule. Do it 10 times. Take it as a punishment and do it one more time. Don't feel it as a burden if you want to learn seriously. Can anybody stand and say the explanation why the scattering angle of photon is maximum scattering angle of photon is 180 degrees? Why it is 180 degrees maximum? By seeing that expression, can anybody tell me? Maximum possible scattering angle of photon is how much? 180 degrees. That is what we said, explained earlier. More than 180 it won't be scattered. By seeing that expression, anybody can say? Right, listen. Tan phi by 2. Here what you are having? Tan phi by 2. Everyone see once. Tan phi by 2. Tan maximum value. Infinity for what angle? That means tan phi by 2. Here it is a phi by 2. What is the angle here? Phi by 2. Phi by 2 equal to tan of something is maximum. Tan of something is maximum. Maximum means for which angle it is maximum? 90. That tan of something. What is something? Phi by 2 equal to. That is maximum. Then phi equal to. Please write that. Tan phi by 2 maximum value is infinity. That is phi by 2 equal to infinity for 90. Then phi equal to 290 is 180. This is the maximum value is infinity. This is possible only for 5 by 2 equal to 90 degrees, then 5 equal to 180. This is the maximum possible scattering angle. That's it. So I request you, please practice all these things. Tomorrow we'll start another new concept. Today if you have any pending work, so the work will be multiplied.
Here's what I found.